Welcome back. Today we are looking at Algebra 2 Lesson 1.6, the first part of it. We are looking at solving absolute value equations and inequalities. Today we're going to focus on just writing and solving equations, and then tomorrow we will tackle the inequalities that involve absolute value. So just a quick reminder from previous years, absolute value stands for the distance from zero on a number line. It will always be a non-negative value. All right, it's not going to be negative. It could be 0 or it could be something positive. In terms of numbers, if you see something like this, the absolute value of 4, 4 is a positive number already, so it's just going to stay a 4. We are 4 spaces from 0. If we are taking the absolute value of negative 4, again, picture on a number line, distance from 0. If we're over here at negative 4, we are 4 spaces from 0. Doesn't matter which direction we go, but in both cases we are 4 spaces from 0. So the absolute value of 4 and the absolute value of negative 4 are both just 4. In symbols, we would say the absolute value of x is just x when x is not negative, so 0 or anything higher. So that's an example like we had here. If we are putting in a 0, absolute value of 0 is just 0, and the absolute value of a positive number is just going to come out as the positive number. If we are taking the absolute value of x and x is negative, so if x is already negative, it starts out negative. When we take the absolute value of a negative number, we are going to get the opposite of what we started with. So if we started with a negative number, it's going to come out as a positive number. So the absolute value of a negative number is going to come out as the opposite of that negative, which is going to be a positive number. So absolute value equations are ones where we have a variable inside the absolute value symbol. And just like we looked at in the examples previous, the absolute value equations can have two solutions. So this one is saying find the values for x that would have an absolute value of 5. That means they want to be 5 spaces from 0. So if we're at 0 here, we can go 5 spaces that way, or we can go 5 spaces that way. Our solutions will be negative 5 and positive 5. They are both 5 spaces from 0. Now when we solve equations that involve, or inequalities that involve absolute value bars, we want to think of the analogy of breaking out of jail. Think of those bars that you see for absolute value as your jail cell bars. Okay? We have to get rid of any guards that would be blocking our path if we're trying to escape. So guards are going to be outside of the bars. So guards will be all of the numbers in an inequality or equation that are outside of the absolute value bars. Now, it's always wise when we are breaking out of jail to have 2 escape routes. So we are going to, once we get rid of any of the guards, we're going to break out of jail and have 2 different equations, 2 different escape routes. We will then solve each of those equations and check our solutions and graph our answer. So let's start with this first one. We have the absolute value of 2x plus 5 is equal to 9. So here are my jail cell bars. In this case, there are no numbers on this side of our equation that are outside of those bars. Everything's inside. So we really don't have to get rid of any guards because in this case we don't have any. When we break out of jail, what that means is we want to get rid of those absolute value bars. But to do that, we have to have 2 escape routes. So our 2x plus 5 is going to be the one side of 2 different equations. One of our equations will be just like what we have initially. The 2x plus 5 could equal the 9, okay? Because the absolute value of 9 is 9. So 2x plus 5 could equal the 9. But the absolute value of negative 9, I'll put it over on this side here, the absolute value of negative 9 is also 9. So our 2x plus 5 could represent a negative 9. In each case, when we take its absolute value, it comes out to be just 9. So let's solve each of these. We're going to subtract 5 to get our constants together. Negative 9 minus 5 would be negative 14. We're then going to divide out the 2. So we have x being negative 7. So one of my solutions is going to be just the negative 7. On the other one, we're going to subtract 5 again. But this time we're subtracting it from a positive 9, so we just get a 4. And when we divide out our 2, we have x equaling 2. So 2 and negative 7 would be the two solutions to that statement. Well, let's check it. All right, we want to check our solutions. So let's plug a negative 7 in here. 2 times negative 7 would be negative 14, plus 5 would be negative 9, and when we take its absolute value, we get 9. If we try to plug in a 2, 2 times 2 is 4, 4 plus 5 is 9. When we take its absolute value, we get a 9. So we have checked them, they both work. Let's move on to the next example. Notice on this one that there are some numbers outside of those absolute value bars. Okay, there's a 3 that's getting multiplied in, there's a negative 1 or a 1 that's being subtracted off. So let's kind of get rid of those guards. We're going to add the 1 to move that guard out of the way. And then we're going to get rid of the guard that's the 3 by dividing it from both sides. So we end up with the absolute value of x plus 2 equaling 3. Okay? So we've gotten rid of all of the guards. We now want to break out of jail. And to do that, remember we want two different escape routes. So x plus 2 can equal either the positive or the negative version of this 3. So it could equal a negative 3 or it could equal a positive 3. Subtracting the 2 to solve this, we get x being negative 5. Or subtracting a 2 over here, we have x being a 1. So our two solutions would be negative 5 and positive 1. And again, we can check those to see if they work. So let's go back to our original statement. We always check them in the original spot. Okay. We're going to plug in a negative 5 initially to see if that one works. Negative 5 plus 2 would be negative 3. The absolute value of negative 3 is 3. We're then going to multiply it by that 3 and subtract that 1. And we get 9 minus 1 being 8, which is what we were supposed to get. Checking the 1. Again, I'm going to start out with everything except the x in my equation. And this time I'm going to dump a 1 in there. 1 plus 2 is 3. The absolute value of 3 is 3. Multiplying it to 3 is 9. Subtracting our 1 gets us back to our 8. So they do both work. All right, I'd like you to pause the video and try these two, and then come back and check your answer. All right, there are no guards on this one, so we'll go ahead and write our two escape routes. Since we want the absolute value to be 4, we're looking for values that would create a negative 4 or a positive 4. Subtracting 2 would be our first step, and then dividing out the 3. So negative 2 is one of my solutions. Over here, subtracting 2, we've got 3x equaling 2. Dividing, we end up with 2/3. So 2/3 would be right about there. All right. Checking our answer. All right, so first of all, we're going to dump in the negative 2 and check that one. 3 times negative 2 is negative 6. Adding 2 to it gives us negative 4, and when we take its absolute value, we get 4. So that one works. Plugging in the second possible answer. The absolute value of 3 times something plus 2 has to equal 4. We are going to dump in a 2/3. 2/3 times 3 is just 2. 2 plus 2 is 4. When we take its absolute value, we get 4. So they do both work. This one has some guards, so hopefully you got rid of the guards before you tried to break out of jail. We're going to subtract the 3 off. And then we're going to divide out the 2. So we have the absolute value of x plus 9 equaling 2. So we're going to break out of jail into our 2 escape routes. So x plus 9 could equal a 2, or it could equal a negative 2. Subtracting 9, we have x equaling negative 11. Subtracting 9 here, we have x being negative 7. So again, we would have a dot here at negative 11 and one at negative 7. Checking our solution. All right, the first one we're going to check is the negative 11. Adding 9 to it is negative 2. The absolute value of that is positive 2. Multiplied to that front 2 is 4. Adding 3 will then get us the 7. So that one worked. Checking the negative 7. Adding 9 to it gives us a 2. The absolute value of 2 is 2. Multiplying the front 2 gets us a 4. Adding 3 gets us to 7, which is what we were trying to get. So again, both of those solutions do work. So some absolute value equations have no solution. I want you to think about that for a minute. Absolute value, we said, is the distance from 0, which means it's going to be a positive value. So if I gave you an equation something like the absolute value of x equals negative 20, right away you would say there's no solution to that, because absolute value is always going to come out to be a positive number. The next hint we have here is to always check for extraneous solutions using the original equation. Extraneous solutions, you may have heard that term before. These are solutions that don't actually work. We haven't done anything wrong mathematically, but by getting rid of the absolute value bars, we create some issues at times. So for this first one, what I want you to notice is that we have x's on 2 different sides. So our absolute value bars here around this 3x plus 2, there's no numbers outside of the absolute value bar but on the same side. Okay, so we have no guards sitting right next to it. But what we have to consider when we break out of jail is that this 3x plus 2 can equal the positive and negative version of this. So it can equal the positive version, which would just be exactly what we have, or it could equal its opposite, the negative version of this. And notice that I put that negative sign in front of the whole quantity because it's not just a single number here. I have a whole algebraic expression. So solving those 2 equations, for the left one, we are going to have to distribute that negative. So we'll have 3x plus 2 equals negative 4x minus 5. Combining like terms, we're going to add the 4x to this side so we can get them together and combine them. So we have 7x plus 2 equaling negative 5. We then would have to subtract our 2. And then dividing out the 7 would get us x being negative 1. On the other side, getting our x's together, I'm going to subtract the 3x over here, which leaves me 1x, and then subtract the 5 back to the other side. So x could be negative 3 or x could be negative 1. So let's check those. Our statement was the absolute value of 3 times something plus 2 has to equal 4 times something plus 5. All right, let's check the negative 1. We're going to plug a negative 1 in for our x. Inside our absolute value bars, we get negative 3 plus 2, which is negative 1. When we take the absolute value of it, we get 1. On the other side, we have 4 times negative 1. Adding 5 to it gives us a positive 1. So that one worked. We would include this as one of our solutions. Checking the second one. This time we are plugging in a negative 3. Simplifying on the left. 3 times negative 3 is negative 9. Adding 2 is negative 7. When we take its absolute value, we just get 7. On the right side of this equation, 4 times negative 3 is negative 12. When we add 5 to that, we get negative 7. And 7 does not equal negative 7. Since those are not equal, this is what we would call extraneous. It's an extra solution that doesn't really work, so we would not include it in our final answer. All right, this is our last question for today. I'd like you to pause the video, try it, and then come back on and check with me. Once again, we don't have any guards around our jail cell, so we're going to break out of jail. So 5x minus 2 can equal the positive version, 7x plus 14, or the negative version of that. So it's opposite. Distributing, 5x minus 2 equals negative 7x minus 14. I'm going to add 7x to get my x's together so I can combine them. I now have 12 x's minus 2 equaling negative 14. I'm going to add 2. I have 12x equaling negative 12, and then I'm going to divide out my 12. So x could be negative 1. For the other version, we need to get our x's together onto one side, so I'm going to subtract the 5x over to pair it up with the 7, which leaves me 2x. I'm then going to subtract the 14. I have negative 16 equals 2x, and now when I divide out my 2, I get negative 8 equals x. So again, we have to check this. So we are starting out 5 times something minus the 2. I keep wanting to put a plus there. Minus the 2 equals 7 times something plus 14. All right, so checking our first one, the negative 1. Inside our absolute value bars, we have negative 5 minus 2. That's negative 7. Its absolute value would be a 7. Checking on this side, 7 times negative 1 is negative 7. Adding 14 gives us 7. Those are equal, so I would include this as a solution. Checking the negative 8. So this time we're plugging in a negative 8. 5 times negative 8 is negative 40. Minus 2 is negative 42. Its absolute value is 42. On this side, 7 times negative 8 would be negative 56. Adding 14 to that gives us a negative 42. And a positive 42 does not equal a negative 42. So I would call this one extraneous, and I would not include it in my final answer. All right, so that is wrapping up our explanation of solving absolute value equations. Tomorrow we will start looking at the absolute value inequalities. Check your Schoology page for the assignment.